Hi, welcome to Algebra 2 Common Core. Today in Lesson 5, we're going to talk about how to graph piecewise functions. You were first introduced to piecewise functions in Algebra 1, so let's review what they look like. Piecewise functions are represented in a way that involve different equations for different portions of their domain. So we will see a notation that looks like this, where f of x is equal to, and inside the bracket it will show several lines with different functions. For each function, it will have to specify what domain is used for that function. So let's go ahead and try exercise number 1. Here we're given the piecewise function that is given by the formula f of x is equal to x minus 3, and that is valid when x is greater than or equal to negative 3 but less than 0. But then in a different domain, f of x will be equal to 1/2 x plus 4, where x is greater than or equal to 0 but less than or equal to 4. So when we're creating a table of values, it's going to be necessary for us to decide if the input value is part of the first function or the second function. So when I look at the input value of negative 3, I see that negative 3 is part of the first function. So I'm going to substitute negative 3 in for x. Negative 3 minus 3 is negative 6. Negative 2 is also in the domain of the first part of the function, so negative 2 minus 3 is negative 5. Negative 1 is also part of the first function because it's in the domain from negative 3 to 0. Negative 1 minus 3 is negative 4. Now, when we get to the value of 0 for an input, we see that 0 is actually part of both definitions. So how will we know which one to use? It depends on the inequality sign that is given. This part denotes that x is used for all values up to 0 but not including 0. This part of the piecewise function says if the input is greater than or equal to 0, then I'm going to use 1/2 x plus 4. So that's the one we're going to need to use because 0 is in that part of the domain. I'm going to graph those values in red, so I'm going to put them in the table in red as well. 1/2 times 0 plus 4 gives me 4. 1/2 times 1, and again notice that all the rest of the values are in the second function's domain. So 1/2 times 1 plus 4 gives me an answer of 4.5. Half of 2 is 1. 1 plus 4 is 5. Half of 3 is 1.5. 1.5 plus 4 is 5.5. And you should notice a pattern here. 1/2 of 4 is 2. 2 plus 4 is 6. Now, when we go to put these points on our graph, we're going to, and again I'm going to switch back to blue for the first half of the function. So when the input was negative 3, the output was negative 6, so I'm going to count 6 down and put my first point right here. Negative 2, negative 5 would be right here. Negative 1, negative 4 would be right here. Now, we can't jump immediately to 0, so we have to really think about what is happening between negative 1 and 0. If the pattern continued at 0 with the blue values, I would have had an answer of negative 3. But because 0 is part of the second function, I'm not going to fill in the circle at negative 3. Instead, I'm going to put an open circle at 0, negative 3, showing that I would have gone all the way up to that point but not include that point. Actually, I made a mistake there. I want to erase everything that comes before negative 3 because that's not part of the domain of any of the sets. Now, at 0, I do want a function value of 4, so I'm putting a filled in circle there. At 1, we want 4.5. At 2 we want 5. At 3 we want 5.5. At 4 we want 6. And again, we're going to stop our line right with that point because that's the extent of our domain. So you'll notice that these two pieces of our piecewise function are actually disjointed. They're not connected at all. But because at 0 I have a filled in circle here and an empty circle here, this is still a function because it does pass the vertical line test, even at 0. Now the next part of the question says, state the range of the function using interval notation. So looking at the blue part first of all, the blue part had an output of -6, which was included in my y values. But remember that we put an open circle at -3, so we're going to go all the way to -3, but -3 is not included, so I put a parentheses. For the red part of the graph, I'm going to start with my range at 4, and again that's the output value. And I'm going to go all the way up to 6. Both of those endpoints are included, so that's why we have a square bracket. The other thing that we should be able to do for a piecewise function is identify the formula for each part of the graph. So if we call this one f of x, we're going to set up our brackets, and we'll notice that there are actually 3 parts to this function. Here's this linear part, here's this linear part, and the last linear part. So we're going to need 3 different functions to represent this graph. For the first one, if I count out the slope of it, and we can start anywhere, I might start right here, and I count and I see that I'm going up 3 over 2. So that tells me that this part is going to have a slope of 3 over 2. The slope, of course, goes in front of the x. Now I can't see it crossing the y-axis, so I don't know just by looking at it what the y-intercept is going to be. But I can do the same thing, and I can count up 3 and over 2 to look at this point right here where that would have crossed the y-axis if it did continue. If we count that, I see that the y-intercept for that would have been +7. So that's one way to get that linear function. Now look carefully at what x values I'm including. I'm starting right here where x is greater than or equal to -8. And I'm going up to this spot where x is less than or equal to -2. Now because all of these pieces are actually connected to each other, I could leave the -2 as part of this linear portion, or I could put the -2 as part of the horizontal portion. But I don't want to put it on both. If I look at the next part of the function, that happens to be a horizontal line. All horizontal lines have the equation y equals in whatever number it's going through on the y-axis. So this one is going through y equals 4, so the second branch is going to have f of x equals 4. Now remembering that I had already included the -2 on the diagonal part of the first function, I'm not going to include -2 here. And again, it's my choice. I could have included it on this portion and not on the previous. I'm going to keep going and say let's let x be less than or equal to. If I look at where that horizontal portion ends, it ends at 3. I again would have the choice of deciding whether the 3 would be part of the horizontal section or the downward section that's decreasing, only included in one part. Now for the last part of this linear function here, this piecewise function, it's going to be a little bit harder to tell what the y-intercept is going to be. So I'm going to look carefully at this and say, let's count out the slope again. And I see that I'm going down 2 over 1, down 2 over 1, down 2 over 1, which means that the slope is going to be -2, and I put that in front of the x. Now, since I don't know what the b value is, I'm going to come off to the side here and say, let's use y equals negative 2x plus b. And I can pick a point on my graph on that part of the linear section. Let's see, that's the point 3, 4, and that point has to be on this section of my piecewise function. So if I substitute that point in for y and for x, I'll be able to tell what the b value is. So for this, I want to say 4 is equal to negative 2 times 3 plus b. That tells me that b is equal to 10. So back up in my piecewise function, that portion is going to be negative 2x plus 10. Looking at the domain for this, I'm going to say, well, let's see here, we're starting at 3, but I've already used 3 in the second branch of my piecewise function, so I'm just going to put a greater than 3 in there. And then it's going to go over to this point right here, which is, of course, 6. So I'm going to say less than or equal to 6. So just to specify, and I know the question didn't ask this, but let's look at the domain of our complete piecewise function. The domain, of course, starts over here at negative 8 and goes all the way over here to 6. So I'm going to use negative 8 to 6 in interval notation as the domain of the whole piecewise function. For the range, I'm going to look for my lowest value on my graph, and for the lowest value on my graph, I see that it's this spot right here. So that y value, if I count it out, looks like negative 5, and that of course is included, so I'm using a square bracket. And then the highest spot on my graph is up here, where that horizontal section was, which is 4. So I can write down the domain and the range for this function as well. If you have any questions about making these equations of piecewise functions, please rewatch the video and come and see me in the morning. For example number 3, we're going to consider the new piecewise function g of x. G of x is equal to 5 minus x, where x is less than 2, and 1/2 x plus 2, where x is greater than or equal to 2. So notice that this time, the place where the function changes value is at the x-coordinate of 2. So the first part of the question says, let's find the y-intercept. Well, we all know that the y-intercept occurs where the x-coordinate, or the input, is equal to 0. So when I look at my piecewise function, I see that 0 would fall under this portion of my graph, or my piecewise linear function, because 0 is less than 2. So when I am calculating g of 0, I'm going to be substituting 0 into the first part of the definition. So 5 minus 0 is giving me an answer of 5. So that's one point that I know is going to be on my graph. At the point 0, at the input of 0, the output is 5. So I'm going to mark that on my graph. Now what we'd like to do is graph the rest of this function. So I'm going to make a table of values, and I'm going to notice that it's going to change definition at x equals 2. So I've got x and g of x. Now this one does not give me a beginning spot on my domain or an ending spot on my domain, so I can start wherever I would like as long as it's less than 2. So I'm going to start with something like negative 2 and go all the way to the number 2, where I'm going to change definition, and then I'm going to get 3, 4, maybe 5 and 6 to get a few points after where it changes to the second part of the definition. So let's substitute negative 2 into the first equation, 5 minus x. So when I substitute negative 2 in, I'm getting 5 minus negative 2, which is 7. Keep going until I get to that x-coordinate of 2. So 5 minus negative 1 is 6. 5 minus 0 is 5. We've already plotted that point. 5 minus 1 is 4. Now, if the pattern continued, that would tell me that at the number 2, I should have the answer of 3. So on that point, at the number 2, an answer of 3, I'm going to put an open circle. For all these other points, negative 2, 7 is going to look like this, negative 1, 6, 0, 5, 1, 4, and I have the first part of my piecewise function. Notice that for this one I can keep going so that I can put an arrow on the end showing that the graph keeps going. Let me switch over to red so that I can get the other half of my graph. 2 is included in this branch, so that means that I'm actually going to have a function value. I'm going to have an output at 2. Half of 2 is 1, 1 plus 2 is 3. So at 2, I actually do have a value of 3. So I'm going to now fill in that dot. So actually this function, the two pieces are going to be connected. Half of 3 is 1.5 plus 2 gives me 3.5. Then I'm going to get an answer of 4, 4.5, and 5. And if you want to pause the video and calculate all of those numbers, that would be helpful. From that first red point that I graphed, you'll notice that my slope is up 1 over 2. So I can also get my graph looking like this, as well as looking at the table of values. So again, these two pieces, the red and the blue, are connected at the point 2, 3. Now for part C, we want to evaluate using the correct formula. A lot of these values are already in our table of values, but for the ones that aren't, we can use the correct equation. So g of negative 3 means that I'm going to be using the first equation. So I'm going to say g of negative 3 is going to be 5 minus negative 3, which of course gives me an output of 8. G of 0 we've already calculated, so that had an answer of 5. That also used the first part of the definition. Now at 2, I'm going to have to switch over and use this part of the definition. So I'm going to have to say 1/2 of 2 plus 2, which of course is giving me an answer of 3. To do 10, I am also going to use the second part of the definition. So 1/2 of 10 is 5. 5 plus 2 is giving me an answer of 7. Now for this next section, it's going to be important that you have your graphing calculator so that we can learn how to graph piecewise functions on your calculator. So if you don't have your calculator, please pause the video and come back with your calculator. Okay, I'm going to write down first of all how we're going to enter the next function using our graphing calculator. So I'm going to say let's go into our y1. I'm going to enter the entire piecewise function in y1. It is possible to use several different functions, but I'm going to put it all into this one y1. Now because I'm doing the next one, I'm going to say parentheses, and my equation is negative 2x plus 1. Now I'm going to begin and end the function with parentheses. Now I have to tell the calculator what domain to use. So I'm going to use a parentheses. I'm going to type the variable x again, and then I need to tell the calculator to use less than 0. Now, where do we find that less than 0? On your calculator, locate the blue second key and then the math key. In the blue second key and then math key, you will notice this is called the test menu, and all of the inequality symbols are located there. So put that domain x is less than 0 inside parentheses. Then because we want to add on another part of my piecewise function, I'm going to put a plus and then write the second function, x minus 4, also enclosed in parentheses. Now because I want to specify the domain, x is greater than or equal to 0, start parentheses again, and again we'll find the greater than or equal to when we go to the test menu, which is located at second math. If you have any difficulty with that at all, please come and see me in the morning so that I can show you on your calculator. So my Y1 line should look like that. You'll see that I've put a snapshot of the calculator screen below so that you can see if yours matches up. On the other end here, I know I ran out of room on the screen, but it would say x is greater than or equal to 0, and then close the parentheses. So, when we are going to graph this, we can go ahead and hit zoom 6 in order to get a good window for this. So take a few minutes, look on your calculator for the graph. You can also look for the table of values and come back when you have created the graph on your piece of paper as well as the table of values. Welcome back. Your table of values, and I just used the table of values right for my graphing calculator, should look like this. Now you'll notice that the 0 is the place where I'm going to change values. So this spot right here is going to be where I switch from the blue graph to the red graph. Now, because the blue did not include the function value at 0, I did have to think about what 0's output would have been if it did continue. So 0's output would have been 1 if I substituted 0 in for x in the first branch. So I'm going to put an empty circle at 0, 1. You'll notice that I've included arrows on both ends of my graph showing that it continues on the ends because the domains did not stop. For the red part of the graph does include the point 0, -4 because 0 is an input for that part of the function. So that's why at 0, -4 I did put a filled in circle. That part of the graph has a slope of +1, so that's why it's continuing in the increasing fashion. You can also take a look at what the graph looks like on your graphing calculator. We'll be practicing some more with piecewise functions when we get to class. If you have any questions, make sure you come in to see me so that I can work individually with you on your calculator. Have a good night.